Okay, folks, this new video is called Slopes and Intercepts, and we're taking this on Halloween of 2016. As normal, these are Cornell notes, so you guys should have your 1.5 to 2 inches on the left side. Just modeling it for you, where you guys are going to do your questions later. And then at the top here, we want to have our vocab bank. Okay, so our vocab bank is slope. We've been talking about this word slope, and we know it's our change of y divided by our change of x. The other names we have for it is rate, growth, and steepness. The steepness is referring to the steepness of the graph. We have this thing called a y-intercept. That's a new word for us. So where the line crosses the y-axis. So if you had a set of axes and the y, or and this line goes like this, the point where it crosses the y-axis, that's considered our y-intercept. And x-intercepts are just kind of like y-intercepts, except instead of passing the y-axis, we're looking for where it passes the x-axis, and so the x-intercept would be right here. Okay, so there's an example of both a x and a y-intercept. So again, most of this semester is this f of x equals rate times x plus starting amount. And we have other names for it. So here's some of the other names. We have this y equals mx plus b. And this is called slope-intercept form. And you might have seen this last year. So this is talking about where m is the slope and b is the y-intercept. Okay, so you could rewrite this equation of f of x equals rate times x plus starting amount. We could rewrite it as y equals slope times x plus y-intercept. And this is how we probably want to be thinking of it when we are graphing. And so now to our first Roman numeral, slope. Okay, so slope. We can find slope given 2 points on the line. We have an equation for that. Okay, so we can find slope given 2 points. So all we need to be given is some 0.1. We'll call those x1 and x2, or in y1. And then some other point, x2, y2. And say we want to make a line that has these 2 points on it. How are we going to do it? Well, it starts with finding the slope. Okay, finding the slope. So the formula here is the change of y over the change of x equals y2 minus y1 all over x2 minus x1. And what that means is that if we have 2 points, okay, and we make one set the ones and 1 point the set of the twos, we can plug them into this equation and find out what the slope is. So here's an example, 3, 7, and I'll say 5, 10, okay? So let's just use our formula. So if we label this as x1, and this is y1, and this is x2, and this is y2, then we're literally going to just plug this in. So y2 was 10, y1 was 7, all of this is over, x2 was 5, x1 was 3. Therefore, the slope of this line is 3 over 2. I'm just doing the subtraction straight across. 10 minus 7 is 3, 5 minus 3 is 2. So we can call this the slope, and we'll use this letter M for slope. Let's go and do another one. Let's try 7, 2, and 4, 3. So I'm going to do the same thing I did before. I'm going to make one x1, one y1. Make this guy x2, y2. So this is the first point we're talking about, and then the second point we're talking about. We're going to plug this into the formula. So just following this formula, y2 is 3 minus y1 is 2 all over x2 is 4 and x1 is 7. So this is going to be equal to 3 minus 2 is 1. 4 minus 7 is negative 3. So the slope of this line is negative 1/3, which equals m. Okay, so a very simple equation. We're just identifying what points we're looking at and then plugging them into our formula. Let's do one more example with a negative number in there. So here's a 4 -3 and -322. Okay, so same old, same old. Identify this as x1, y1. This is x2, y2. Okay, and we're just going to plug it in. So go grab y2. It's 22 minus, y1 is -3. So -3 all over x2, which was -3 minus 4. Okay? When we have two negatives right next to each other, really what that's saying is instead of doing 22 minus -3, you're actually adding. Okay, so this is going to be 25 over -3 minus 4 is -7. That means the slope of this line is -25/7, and we'll call that m. Okay, this is our slope formula, and we are going to use it tomorrow in class. Okay, Roman numeral number 2 is intercepts. So in A, this is how we find the x-intercept, and we do it by letting y equals 0 in an equation. Okay, all x-intercepts have a number and then 0 as the y-coordinate, and vice versa to that. Okay, is if we find the y-intercepts by letting x equals 0, because all y-intercepts have a 0 for the x component and some number for the y. Okay, so again, for x-intercepts, we let y equal 0, solve for x. For y-intercepts, let x equal 0, solve for y. So here's an example. Y equals 3x plus 12. We want to find the x and the y-intercept. So what I do is I set up two equations. I do this. First, I'm going to do the x-intercept. And if I'm following my directions, it says that I'm going to let y equal 0. So let's see. Y equals 0 equals 3x plus 12. At this point, I just want to solve for x. So I'm going to go through my normal steps of SAD MEP, right? We're doing PEMDAS backwards, SAD MEP. So is there any addition or subtraction I can pull away from x? Yeah, it appears there is. Let's see. I can go -12, -12, get that 12 to the other side. So now I have a -12 equals 3x. I'm going to ask myself, what is that 3 doing to the x? Well, that 3 is multiplying x. And to undo multiplication, I'm going to divide. This gives me that -4 equals x. Now, just because we've gotten that doesn't mean we're done. We want to report this as an intercept. So I go back up here and I say, hey, the x-intercept is -4, 0. Okay, next we're going to do the y-intercept. Okay, if I'm following my directions, it says for y-intercept, I'm just going to let x equal 0. So let's see. Y equals 3 times 0 for x plus 12. Let's see, that gives me y equals 0 plus 12. But do we usually write zeros in our math? No, we usually don't. So I'm going to say that y equals 12. Now, we're not done. We want to go back and report this as an intercept, and all intercepts have a 0 for x. That's what we plugged in, and 12 for y. Okay, let's go ahead and do one more example before I let you guys go. Y equals 2x minus 6. Let's find both the x and the y-intercept. So, first, x-intercept. To find the x-intercept, I'm going to let y equals 0. So 0 equals 2x minus 6. Now I solve for x. So add 6 to both sides. This gives me 6 equals 2x. Divide by 2. Gives me 3 equals x. I'm not done. I'm going to go report this as an intercept. The intercept of x is 3, 0. Next, let's do y-intercept. I'm going to let x equal 0. So y equals 2 times 0 minus 6. This is y equals 0 minus 6. Do we usually write our zeros? No, we don't. So y equals negative 6. We're not quite done. Want to make sure we go back up to the top here and report this as the intercept of 0, negative 6. This is an intercept, okay? Leaving a coordinate. This right here is not an intercept. This is just y equals negative 6. Okay? Go ahead and put a 3. We will add to this a little further, okay? But not today. If you guys are going out tonight, please have fun, but please, please, please be safe. Love you guys. We'll see you guys next time.